Hello, ladies and gentlemen, boys and girls. My name is Adam Weinstein, and today I will be talking to you about the lovely Lewis blood group system. Just to the right, I have provided a brief rundown of the topics that I will be covering throughout this lecture. Okay, so we're going to kick things off here with a couple quick facts that I hope will give you a general understanding of what the system is before I jump into the specifics. So, one fact is that these are the only red cell antigens which are not produced by the red cells themselves, but rather they are absorbed onto the red cell membrane. And this is a key feature that distinguishes them from other blood groups such as KEL, because we know that the KEL antigens are formed directly on the red cell membrane. So you see the difference? Uh, Lewis antigens are absorbed, KEL antigens are formed directly on the membrane. Now, another fact is that the Lewis antigens are found primarily in secretions where they exist as glycoproteins and in the plasma where they exist as glycolipids. And it is via the plasma that they are absorbed onto the red cell membrane because, well, glycoproteins can't be absorbed. And the secretions, though, such as sweat, saliva, and other bodily fluids, is probably the most significant of the two. And this is where our friend, the secretor gene, is going to come into play, and he's going to play a particular role in the expression of one of the Lewis antigens. Okay, so moving on to the molecular structure, it's essential that we begin with a starting point, and that's going to be the type 1 chains. Now, what makes up the type 1 chains are these carbohydrates, DGAL and GLC-NAC, and a protein. Now, the Lewis antigens in particular are formed from this chain in a similar manner, but not the same as the H antigen. So, as you can see, the secretor enzyme is what's going to add fucose to the DGAL end to form the H antigen. For the purpose of the Lewis antigens, they rely primarily on the Lewis gene to add fructose for the expression of either the LEA or the LEB antigen. So as you can see with the Lewis A um, at the top here, the Lewis gene adds a fructose onto the GLC-NAC, and that's what expresses the Lewis A antigen. Whereas for the Lewis B antigen, the deal with this is that, so from the previous slide with the H antigen and the secretor adding the fructose onto the DGAL, we have the same structure, but now we have the addition of the fructose from the Lewis gene on the GLC NAC. And this is what expresses the Lewis B antigen. In the previous slides, I went over how the Lewis antigen structures are formed, and it should come to no surprise that the three key players responsible for their expression, both in secretions and on the red cells, are the Lewis, H, and secretor genes. So let's break down the Lewis A and Lewis B inheritance into simple terms. When we're talking about Lewis A, for example, being expressed over Lewis B, either the secretor gene, H gene, or both will be amorphs. Because Lewis A is like, I'm Mr. Independent. I don't need you, but if you want to come with me, then only one of you can come. So we're going to label this fool as a non-secretor. And what this means is that Lewis A will be the only antigen expressed in the secretion and on the red cell. Then we got Lewis B. And Lewis B is just the opposite of Lewis A because he's needy and not as selfish. He's like, listen, secretor H, I can't express myself without you here with me. So we're going to call those that are Lewis A negative, Lewis B positive, the secretors. And thus, they will be able to express Lewis A, Lewis B, and H in their secretions. And of course, Lewis B will be expressed on the red cell. If we look at the chart showing the possible phenotypes and their frequencies for the Lewis system, you can see that the most dominant phenotype among both the black and white races is Lewis B, and we know that those who express this antigen are the secretors. However, the non-secretors, those who possess Lewis A, are shown to be significantly less frequent in both races. And furthermore, those that display neither or both phenotypes are even more rare, especially among the white population. In terms of their clinical significance, the Lewis system actually lacks any clinical significance. And this is to say that if a unit of Lewis positive blood were to be transfused into a recipient who is Lewis negative, the donor's antigens would neutralize the antibodies and a reaction likely wouldn't occur. And it's always safe to perform a cross match, but transfusion reactions are rare. And since Lewis antibodies are of the IgM class, there's a low probability that hemolytic disease of the fetus and newborn will occur because these antibodies can't cross the placenta. So there are a few methods that are used to detect the presence of Lewis A and or Lewis B antibodies, and one is test tube agglutination. When properly performed, you should see agglutination in not only the immediate spin phase, but in the 37 degrees Celsius and AHG phases. And normally, for IgM antibodies, they react best to room temperature, but the potentiator enzymes in this case enhance the reactivity, especially with anti-Lewis B. Another technique is neutralization. And the principle of this method is that by combining a commercially prepared substance with the patient's serum, the soluble antigen in the commercial product will inactivate the antibodies in the patient's serum if they are in fact present. And that concludes my presentation on the Lewis blood group system. Thanks for watching.